Okay, we're going to start section 12.4 and talk about how we actually use the standard deviation that we calculated in the last section and what it's kind of used for. And we're going to start talking about normal distribution. And so a lot of times certain data is collected and it ends up being kind of normally distributed. For example, things like heights, weights, even some tests that we take are what we call normally distributed. And they kind of end up going into what we call a bell curve, okay? Normal distribution is a bell shape and is symmetric about a vertical line through its center. And the mean, median, and mode are all equal and located at the center. And so we can randomly select and sample 100 men, figure out their heights, and we end up kind of getting this bar graph here, and if you kind of outline it, it looks like a bell curve. And the more men you survey, the more it kind of smooths out and turns into this normal distribution. Okay, so again, a lot of things are normally distributed, and we can kind of use that to make predictions and make conclusions about certain data. And so the mean is in the center of our normal distribution, and depending on how widespread the data is, you might have a bell curve that's a little bit skinny, or you might have a bell curve that's kind of a little bit on the fatter side. Okay? Normal distribution again is used to make predictions about an entire population using the data from that sample. And so let's talk about standard deviation, how we're going to use it, and what we call the 68, 95, 99.7 rule. Okay? We use this rule anytime we have a a normal distribution, and we know what the standard deviation is. And so the middle number is our mean, and if we know the standard deviation, we can figure out what number is then one standard deviation above and one standard deviation below our mean. We can then figure out what number is two standard deviations above and two standard deviations below, and then again at 3 above and 3 below. Now, once we have these numbers, what this rule says is if our data falls within one standard deviation away from the mean, either one above or one below, what it's saying is that 68% of the population should fall in that category. If we're one standard deviation away from the mean, about 68% of the population should fall in that group. Now, what it also tells us is that if we're two standard deviations away from the mean, then that means 95% of the population falls in that group, right? The majority of our standard deviation bell curve should fall in that category. Now, you know that we go up to 100%, so there's still some people that are outliers, some below, some above. But if we fall within two standard deviations of our mean, that's about 95% of the population. The rule is a 68, 95, 99.7 rule, meaning that if we fall 3 standard deviations away from the mean, about 99.7% of the population should fall in that category if we have a normal distribution. Now again, there's still a little bit above or a little bit below, but 99.7% of the population should fall within 3 standard deviations of that mean. Let's work through a few problems in this video talking about normal distribution and that standard deviation. So if you look at example number 1 with me, it says here that adult male heights in Northern America are approximately normally distributed. So it follows that kind of bell curve with a mean of 70 inches and a standard deviation of 4 inches. Find the height that is 2 standard deviations above the mean. Well, if we know that the mean is 70, we can start with that. If we know that each standard deviation is 4 and we want to have 2 of them, can I take 2 times 4, which would really give us 8? And if we want to make sure we find the height that is above the mean, then we want to take that 8 and we want to add it to our mean so that we are 78 inches. If our mean was 70 and we're 2 standard deviations, which means 4 each, then we end up at a height of 78 inches. So if I say I'm 2 standard deviations above the mean, then that means I'm a height of 78 inches. Let's do another one. It says here in part B to find the height that is 3 standard deviations below the mean. Now we have to be careful that we're reading the questions carefully because this one's a little bit different because it says we're going to be below the mean. So now we have to start at the mean, which is 70. We know we want to do 3 standard deviations, and if 3 standard deviations, if each one is worth 4, then we really have 12. But this time we want to be below the mean, so we want to make sure that we subtract. If we are 3 standard deviations below the mean, then that really means we're 58 inches tall. So we should be able to figure out heights if we know the mean and the standard deviation. We can kind of figure out where we're at on that bell curve. Okay? So let's apply the 68, 95, 99, 7 rule. So it says here 1,000 students take an exam with a normal distribution, so it follows that bell curve. The mean is 75 and the standard deviation is 7. And so if we were to make our own chart, it says here that we have a mean of 75, so that number would go in the middle, and we have a standard deviation of 7. That means if I add 7 or subtract 7, I'm within 1 standard deviation of the mean. So 75 plus 7 is 82, 75 minus 7 is 68. So that's how they got those numbers. If I add another 7 and subtract another 7, then I'm 2 standard deviations away from the mean, 61 and 89. If I do it again, add 7, subtract another 7, I'm either at 54 or 96, and that means I'm 3 standard deviations away from the mean. So if I didn't give you the chart, would you be able to create that chart yourself? You might want to pause the video, cover up the example, and find those numbers again by yourself so you know how to do that. In this example, it says that we want to find or know how many students scored above an 82. Well, when I go back to my chart and I find the 82, it's right here, and we know that we are within 1 standard deviation if we fall at an 82. And we know that 68% of the population falls in that category. But it doesn't ask us that. It asks us what percent or how many are above 82. So we really want this amount. Well, if 68% of the population fall in the category, then doesn't that mean that 100 minus 68 fall outside of the category? And so what would that be? Wouldn't that be 32%? And so if 68% are inside, then that means 32% are outside. But again, I don't want both of those. I only want the amount that's above. So then I've got to take that 32 and divide it in half, so I'm only looking at the top half. And so I can say that 16% of the students scored above an 82%. Now, the question also didn't ask me what percent, it asked me how many students. So I know that there were 1,000 students, and I know that 16% of them scored above an 82, so we've got to figure out what 16% of 1,000 is. So I'm going to take 1,000, I'm going to multiply it by 0.16, and I end up getting 160 people. That means 160 people scored above an 82% using that 68, 95, 99.7 rule. Let's do another one. It says in this one, if we want to know how many students scored below a 61. Looking at our chart, we have our mean, we have our 1 standard deviation, we have our 2 standard deviations, and here's my score of a 61. It's asking us what percent of people scored below a 61, so I'm looking for this amount. Well, we know that 68% of people fall in 1 standard deviation, and that 95% of people fall within 2 standard deviations, which is our border line at 61. And so if I know that 85% of people fall in this category, then doesn't that mean that the other part falls outside? So what's 100 minus 95? 5%, right? Again, 95% fall within because I'm 2 standard deviations, because that's what the 68, 95, 99.7 rule says. So if 95% fall in the category, then that means 5% are outside of the category. But I don't want to know how many people are below and above. I just want this half. So I'm going to take the 5 and divide it by 2. And so then you should end up getting 2.5% of people scored below that 61%. But the question says how many students, so let's figure out how many students it means if 2.5% of them are below a 61%. We knew that there was 1,000 students. We're going to multiply it by 2.5% or 0.025, and we end up getting 25 people. 25 people scored below a 61%. We can get that by using our 68, 95, 99.7 rule. Practice that. Make sure you understand those before we do some more examples in the next video.